Hello all, welcome to Chip Talks. Today we are going to see the VLSI design flow. Previously we had seen the what is VLSI, why VLSI and its importance and its applications. Today let we see the VLSI design flow. Okay, let we start the video with some example. Okay, if you are using a mobile phone and we are watching some videos in YouTube or Instagram. Okay, inside that mobile phone a processor will works. Okay, inside that processor we have multiple thousands to the billions of transistors working. Okay, how it's designed. Today videos how the chip is designed. Okay, from starting specification to fabrication. Okay, let's start with our video. Today video is, first of all, welcome to Chip Talks with Madan. Okay, our video title is VLSI design flow. Okay, first of all, the design flow starts with some specifications. 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 Okay, specifications means okay. Specifications means okay, we have a client. Okay, I am a product manager. You are a client. Okay, you are telling I needed some specifications like performance. I need a better performance. Okay, and power and area and functionality will functionality. Okay, so I'm a product manager. I get that specifications from you. Okay, so I will work on the specification and design for the specification. Okay, let me consider a scenario. Okay, if you have a dress. Okay, you need to switch. Okay, you need to switch the dress from tailor. Okay, you are going to tailor shop and giving some instruction and specifications to tailor. Okay, we need I need a tight shirt, I need tight one, I need a loose one. Okay, consider that specification, the tailor will stitch the dress like that. The client will tell okay how the chip will works. Okay, how the chip we want, like functionality, power, area. So that with that specification the product manager will work on that specification. This is how the specification works. First one is like power. Example I am telling, we have many specifications. Okay, power. Second one is functionality. It will tell me 1 minute. Power. Second one is functionality. Okay, third one we can say performance. Okay, this is how the specification works. Next about, okay, second one is RTL coding. RTL coding or RTL design. Okay. Okay. The client will give some specification to the product manager. Okay. After that, we need to write some logic to that specifications. Okay, logic means how the chips works, basic idea, basic architecture, basic idea we can tell. Okay, RTL means, the full form of RTL means register transfer level. Okay, register transfer level. Transfer level. Okay, register transfer means okay, we need to write a logic. Okay, the logics are about the specification. Okay, you can say RTL is here like a bridge. Okay, RTL is here like a bridge between algorithm and hardware. We can tell RTL is a bridge between um, what algorithm. Okay, algorithm and hardware. Okay. The basic RTL engineers will write some logic. Okay, logic in the sense they will write some coding. Okay, in software you use Python, Java, C, C plus, okay, etc. Same like that we will use coding also here. Means hardware description language. Okay, we are using hardware, so we need to write hardware description language. Okay, HTL. You can tell HTL. The logic written in the form of hardware description language is a hardware description hardware description hardware description language. Okay, we have said two languages. Okay, one is we have many Verilog. Okay, second one is VHDL. Okay, VHDL. VHDL. Okay, these are the hardware languages used to write logic. Okay, logic for the specifications. Next, we can tell RTL is the foundation of digital design and design flow. Okay, VLSI flow. Tell RTL is the foundation of digital design and wait, okay, and design flow. Okay. What exactly the RTL will do? Okay, means like consider, okay, they will register transfer means, okay, they will transfer that logic, okay, they transfer the data from one register to another. Okay, register means, okay, a memory. Okay, register means a group of flip-flops. Okay, we will discuss that register, flip-flops, latches later. Okay, I will tell some orally. Register means a group of flip-flops. Okay, flip-flops nothing but memory storage element. Okay, storage means a one bit of memory. Okay, we will save in that flip flop. Okay, like that it will memory saved from one place to another. Okay, moving from one place to another, like we consider mm, r3 r r3. Okay, r3 is the storage. Okay, r3 is the storage. We where need to where where we need to save that memory. Okay, we are getting some input from r2 plus some r1. Okay, okay, we have data from r1 and r2. Okay, we are doing some addition in the sense combination will place. Okay, first of all, r1 r2 r3 are registers. Okay, registers are, I said, memory. Next, the addition of plus is about combinational circuit. Okay, combination means like adding separate add sub will come. Okay, next one is we have control signal clock. Okay, this combination is this collaboration is called RTL. Like we can say, first of all, register. Second, we have register means sequential circuit. Okay, consider sequential and the I said plus. Okay, operations are comes under combinational. You know that already we know combinational and sequential difference between. Okay, I will tell explain. Okay, combinational. Okay, see, first of all, sequential we have memory. Okay, but in combination we don't have memory. That's the difference. Okay, registers. Next, combinational. Next, we have mm, clocks, control signal. Next, we have clock. Okay, this about the RTL will works. Okay, RTL is nothing. RTL is about writing logic. Okay, logic using some HTL. Okay, hardware description language. Okay, this logic so works like a flip flops. Okay, flip flops. Okay, like we can say yeah, registers. Okay, register means flip flops. Okay, okay, this code will work so flip flops. Okay, next one is design functional verification or design verification. We can tell functional. Third flow is functional verification. Functional functional verification. Functional verification. Okay. Functional verification is nothing. Okay. The RTL team will write the code for the specifications using some hardware languages at Verilog and VHDL. Okay. Okay. We need to verify that logic. Okay. So that only the logic works performs correctly or not. We can identify. Okay. The functional verification is nothing but identifying the logic works perfectly or not. It's about it's about the written logic, the written logic of the RTL team. RTL team, okay, RTL team is is verified and checks performance. Okay. If the RTL team written some code, okay, written some code logic, okay, and it's verified, and it's some we get some error, okay, okay, and that logic again the logic will go to the RTL team, and they will correct that code, okay, they correct the logic, okay. How that functional verification team identify means using some test benches. Test benches nothing but inputs to the logic, okay. Test benches, sorry, test benches means inputs inputs to the logic, okay. Okay, this is about the functional verification. Next synthesis, the important one. Fourth one is synthesis. Thesis. Okay, synthesis is nothing but, okay. After verification, we have that code RTL code. Okay, RTL code is converted into gate level net list. It's about synthesis. Let me explain. Okay, we have RTL code. Okay, RTL code, RTL code into gate level net list. Okay, we will convert RTL code into gate level netlist. Gate level netlist means, okay, we have written some logic. We can set the logic. I set registers and some of the flip flops. I said no, that are converted into gate level. Gate means logic gates. Okay, it looks like say logic gates. The synthesis role is code is converted into a gate form, okay. It's about we can say AND gate, OR gate, NAND gate, anything gates, okay. The synthesis is nothing but code into conversion of gates, okay, using tools, okay. We have used synapses, cadence, okay, like the tools. We will convert the code into main purpose code into gate level netlist. Gate means nothing but logic gates. Gate level means gate level means gate level means what? Logic gates are logic logic gates like and or sorry, or and anything etc, okay. It's about the synthesis. Next comes under DFT, design for testability, okay. We are converted into gate, okay. Okay, fifth one is DFT, design for testability. Design for test, we can tell DFT, okay. Can tell design design for test. Okay, design for test. Design for test means, sorry, I written DD. Okay, design for test means, okay. First of all, the DFT people will add some extra logics. Okay, extra logic in the sense, okay, they will convert after converting gate level nest into, they will make some sample chips. Okay, okay. Uh, After that, they made sample chips. Using the sample chips, they will give some inputs. They work. They will verify that chips are working under good conditions, or okay, or if they perform any bad, they will add some extra logics to to work well, okay. That role is the for DFT people will come. The DFT people will write extra logic, we can tell extra, they write extra logic, okay. Or they made a, and they will made and they will made some sample chips, Okay. Okay. If after the DFT, they will go to directly go to the PD people. Okay, PD. Next one is physical design. Okay. If the if goes to PD means we can't change the logic. Okay. So the DFT people will come, okay, and made some sample chips and works, okay. They will check the chips are really working under good conditions under some test benches, okay. So if there is an error, they will add extra logic, okay, okay, and it's about the DFT people, okay. Next we are going to see physical design. Sixth one important, okay. Physical design is like. Design on the silicon chip, okay. Design this is last, okay. This is last, okay. Physical design, okay. This is about, okay, before physical design, we have logic, we have logic, okay. Logics are converted to gate level net list, okay. So the we have gate level net list up to gate level net list, okay. That we are converted into that are going to convert into physical design means layout, okay. The layout means, okay, we are placing, okay, we are manufacturing chip, okay, on the silicon. Silicon in the sense chip, okay. Chip design, okay. Silicon, how the chip will looks like, it's about physical design, okay. In in that, okay, we have floor planning. I will explain deeply about physical design in another playlist, okay. Okay, floor planning, okay. Floor planning in the sense area, okay, how much area that chip design, okay, chip needed, okay. Okay, physical design plays in, okay, physical design is the where the chip going to fabricate, okay. Before that we have only the logic code, okay, gate level netlist. In that physical design only we are going to create some layout. After that layout, it will be fabricated to chip, okay. Yeah, entire chip. Next one is like floor planning placements. Sorry, placements means we are placing some cells, okay, standard cells. Next is standard cells. I will explain clearly about deeply in some other videos. Third one is like a clock tree. See, it's a clock tree synthesis. Okay, clock means we are giving inputs. Clock tree. Okay. Fourth one is routing. Okay, routing in the sense we are connecting some all that cells. Okay, routing, routing, and here also verification will come. Verification means physical verification. Physical verification means how, okay, physical verification. Okay, like physical verification means okay, we are created floor planning placement. Placement means I said we are placing some cells. Okay, physical verification team will check that placement of cells are correctly placed. Okay, we are given correct clock signal. Okay, and we made correct. Routings, okay. Routings in sense connections to that cells, okay. It's about the physical design team will do, okay. This entire this five things will be done using tools, okay. Synopsis, cadence, okay. Individual floor planning will have separate tools, okay. Placement will have separate tools, okay. This is about physical design. Physical design, I said, if anyone asks physical design means, it directly tell, okay, that gate level netlist into a layout on the silicon chip, okay. How the chips, okay. This is about the fabrication step. Next one is STA means static analysis, okay. Static analysis, okay. You see a bad it's a important one, okay. Chip, static 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 time analysis. Static time analysis means, okay, we can say chips on chips. works under certain time requirements. Okay, this is if you know as STA means the chip should works under certain time requirements. Okay, requirements with specifications. Okay, chip should certain time requirements. Okay, we say some we we say some whole time and whole time and we can say setup time. Okay, setup time. Okay. I will explain the STA physical design deeply. Okay, if you explain means that the video will be time will be more. Okay, time will get more. Okay, next one is eighth one. Sign off. Sign off. Sign off means mm, sign off means the after the all verification. Okay, it's going to sign off means all the designs are sign off. Okay, it's going to fabricate the chip. Going to fabrication. Okay, the layout are going to fabricate on the silicon chip, silicon silicon material. It's about going to get sign off from the layout. Okay, layout and placing on the silicon material. Okay, next one is fabrication. Ninth one is fabrication. Fabrication means fabricating the chip. The entire chip is manufactured using the design physical layout, the logic, RTL design, okay, gate level net list. Okay, Fabri fabrication. Chips are manufactured. Okay, tenth one is again they will do some verification also. Okay, chip verification. They will not. Okay, they will first they will create some sample chips. Okay, and they will do some verifications. Okay, they are working some under certain specifications, or if they or the chip the or if the chips or any doing some mistakes or not doing properly means they will again write go to the DFT people or RTL team. They will write some logics. Okay, again. Okay, they will again logic. They will then they will come to physical design. They will do floor planning, placements, clock trees, routing. Okay, and then STA, and then will sign off, and then goes to fabrication. After that also they will do some chip fabrication. Okay, at last when the chips, okay, 100% working means only they will go to that smartphone. Okay, go to that smartphone process. Okay, they will use that chips in the smartphones, laptops, or any electronic gadgets. Okay, chip verification. Chips. Chips. Okay, that's all. It's about that. We have seen that VLSI design flow. Okay, in that I said STA physical design. Okay, we need a separate video to explain all detailing. So I didn't explain fully in that fully about physical design, STA. Okay, I said some oral points here. Okay, today we have seen um, specifications. Okay, this VLSI design flow specifications, RTL coding, and functional verifications, synthesis, DFT, physical design, STA, signing off, fabrication, chip verification. It's all about the design flow. Yeah, the design flow. Okay. Um, After that video, we will get an idea. Okay, it's about the how the chips are designed. Okay, so if you have any doubts, please comment in the comment box. Okay, and see you in the next video. Bye from Madan. That will discuss about some important topics in the coming videos. Bye from Madan.